Hello everyone, welcome to my first episode in this Lua tutorial series. I'm pretty excited to restart this whole series because my old one was, first of all, nowhere near complete, and I wasn't that proud of the videos that I made, so I'm hoping to correct that. And I'm a little bit more organized now, so for this entire series I'm going to be organizing everything in this folder that I have here, which I'll also probably have a download for. I'll probably finish the name of the chapter at the end of every chapter, so I think that'll make it a little bit easier. So we're starting at chapter 1 here, and I just have this introduction .lua file, because this is just going to be an introduction video to Lua. Mostly just explaining the very basics, like what you should really know right off the bat. So we're going to go in Sublime Text here. Also, I will have a download to Sublime Text in the description of this video if you guys want to check it out. I do highly recommend that you at least look at it. It's one of my favorite text editors, and it's just overall pretty good. It's beginner friendly. It's not an IDE, but you can use it to run code, and it does have an output window. There's some cool debugging tools in it. So, alright, so getting started with today's video, I have all the topics that I want to cover in this video listed out right here. I do want to keep this format going for the rest of the series, so get used to seeing this in all of the new videos in this playlist. If you want me to change any of it or anything like that, always leave a comment and I'll read it. But anyway, the first thing we're going to talk about is comments. So in other languages, the syntax for creating a comment differs very widely, but in Lua, you can see here I start out, this is a multi-line comment. It's a variation of two different kinds of comments you can make. You can make single-line comments like this, and you do that by using two hyphen symbols, and then following that by your text. So I'll just say comment text. And you can see if I go down to the next line after that, it's no longer going to be highlighted in that kind of light green that indicates a comment. So if I go to the next line, and I just type out anything else, you can just see it's in your standard syntax highlighting for what's going to be ran as code. And then for a multi-line comment, it's very close. It's just two of those hyphen symbols followed by two opening square brackets. And anything after that until it's closed by two closing square brackets is going to be considered a comment. So it's kind of like a block of text rather than just a single line. So anything in between here is just going to be a comment, just like this block right here. Also, if you're unfamiliar with the term syntax at all, I just brought that up because I have that listed in my terminology pool here. Syntax is basically a synonym for grammar. So you can kind of think of the syntax of a programming language as the grammar for whatever your spoken native language is. So just kind of the rules of writing is basically what syntax and grammar do, and they kind of go hand in hand. And when I mentioned the kind of like highlighting, like the text color for comments, and you see that it's like kind of in a light green, that's usually known as syntax highlighting. And you always want to have a text editor that supports syntax highlighting for your language. It just makes learning it a whole lot easier, and it's just a lot easier to look at. Alright, so moving on from that, let's go ahead and talk about variables. Now, if you don't know what a variable is, it's one of those terms that's just kind of universal in any kind of programming language or math or any kind of logic system. You're always going to hear the word variable, and so you definitely want to know what it means. And across all of those subjects, it usually always means the same thing. A variable is just something that has some kind of assigned value to it, but doesn't necessarily equal the value itself. So basically what I mean by that is if I want to create a name for something, a name is a good analogy to this. So in real life, human beings like you and me, we have names. So you can kind of say that our name is kind of like our variable. If someone shouts out your name in school or at work, that is a natural way to kind of invoke your attention. So whenever your name is used, it's essentially a supplement for yourself. So in programming, the way that we create variables is that first we want to identify a variable name. And there's some limitations to what your variable name can and can't be, but I'll get into that later. So for now, let's just say that I want to call a, let's say that I want to make a variable for a number. So I'll go ahead and call my variable, we'll just call it number. Pretty specific. And I'll just set that equal to 10. So the syntax for creating a variable is pretty simple. You have your variable name on the far left, your assignment operator, which is this equal sign, and then whatever value you want that variable to be assigned to. So in this case, it is the value of 10. So why is this useful? What is it used for? Why do I have to do this instead of just using the value of 10? These are questions that may or may not be crossing your mind if you're not that familiar with variables. Basically, it just means that there's multiple reasons. One, it could make it easier if you want to reference this value multiple times in your script or in your program, and you still want to be able to easily change it. So you still want to have access to it. So, if I'm in my program and I'm like, using numbers like 10 everywhere, willy-nilly, and, later down the line I decide, you know what, I don't really want this to be 10. I want it to be 5. Now I have to go back in my program and change every instance of 10 to a value of 5, and it's just really annoying, and you don't want to do that. So in one case, for one scenario, you could use a variable to kind of have that data centralized in one spot, and you can just use the variable name that you assigned your value to as a supplement in your program. So now, if I want to use the number 10 in my program, I can just create a variable for it. I'll call it number. And every time I use number in my program, it's going to reference that value of 10. So if I decide later I don't want this to be 10, I want it to be 34, then in my program, it's just going to say, okay, well, number is now 34 instead of 10. So, I only have to change it here. I don't have to go back and change, all of the occurrences later in my program. Readability is another reason why you should be creating variables. Readability is basically just, I should probably actually add that to my terminology thing here. I'll call it readability. So readability just means how readable your code is, essentially. It's pretty self-explanatory. So when you hear programmers talking about readability of your code, what they're basically saying is how easy is your code to understand in whatever your native human language is. So in this case, the readability of this program is pretty good so far. We have a variable called number, and we assigned it a number value, so that makes sense. We can look at this and make sense of it without really even needing to know that much about programming. So that's what readability is, and usually you want your code to be as readable as possible. So whenever you can, if you're declaring a variable name, always make sure that whatever the name of your variable is resembles as much as possible what the value of that variable is. And I suppose the third one of the major uses of variables is that you just might not know what the value of something is. So, if you have a program that takes input from a user, the program doesn't know what the user's going to input. They could input a number, they could input a letter, some weird data that isn't even valid. So it's up to the program to take that input, assign it to a variable, and then have the program evaluate that variable later on in the logic of the code. So that's what a variable is. This is how you create a variable inside Lua. You might notice that I have this kind of part 1 in parentheses here. That's because if you've done any prior research to watching this video, you've probably seen local variables before in some other videos or other code, where they'll have this keyword local before the actual variable name. So they might say local number equals 34 or something else. And I'm going to get into, that'll be, variables part 2, which I'll discuss in probably I don't know when, but I'll discuss that later on in the series. But for the purpose of this video, to avoid any confusion, we're just going to only pay attention to this kind of variable. So we're going to get rid of that. And just to address the keyword term that I used just then, a keyword in a program is essentially a word that already has a predefined meaning within your code. So I have all of the keywords for Lua listed out here that I got from the Lua reference page. So each and every one of these words you cannot use as a variable name, for example, because it already has a specified meaning within your code. So for example, if I couldn't say like I couldn't call number repeat or local or not. So if I get rid of this and I tried to do that, you see it's just going to be highlighted as a keyword. So one of the limitations of creating variable names is they cannot be a keyword. So I guess we'll kind of segue that into limitations of variable names. So number one, variable name cannot be a keyword. One of the other limitations is that your variable names cannot start with numbers and they cannot contain symbols. So I don't know if I would group those two as one or two different limitations, but I'm just going to group them here. So for example, you can't have a variable name that starts with a number. Like I couldn't say one number equals 34. You can even see in the syntax highlighting that 1 has a different color here because the program is reading this as the value of 1 rather than being included within the variable name itself. So this alone should already indicate that you're doing something wrong there if you see that there's different syntax highlighting for something that you don't expect. And as I said, it can't have any symbols in it either. The only exception to the symbols rule is that you can have underscores in variable names. So I could say number underscore variable equals 34. That's completely valid, but I couldn't have something like number exclamation mark or number $sign or something like that. So variable names cannot start. I'm going to put start in all caps because variable names can have numbers in between letters and after letters, but just not at the very beginning of a variable name. So they cannot start with a number and cannot contain any symbols except for the underscore. So again, I'll just give a couple examples of that. So this would be a valid example of using numbers in a variable name. I could say number 1 equals 1, number 2 equals 2. An invalid example would be if I said something like 3 number equals 3, or number exclamation mark equals 4. Those would all be invalid. And I'm just going to go ahead and put these in comments real quick so it doesn't mess with our code if I decide to run any of this later on. So we'll do that. I'm just going to get rid of this. And the third limitation is that variable names cannot contain space characters. So variable names cannot contain space characters. So if your variable name has multiple words in it and you want to separate those words, you cannot do so by just putting a space in between the words. So I couldn't say something like my number variable equals 10. This would be read as it might not display as a syntax error, but it would be a syntax error given that your intention was to set this as one variable. So if you want to separate words in a variable name, the best way to do that is by using a variable naming convention, which just means how programmers typically structure their variable names, which is called, I believe it's either camel case or lower camel case, which I believe is just starting off your first word with a lowercase letter, and then every word after that just has an uppercase letter, and they're all side by side. So instead of saying my variable name, I could just say my, and then I'll capitalize variable, and I'll capitalize the N in name. And that's usually just easier to read. That's why it's a very popular convention for variable names. The other thing is that the reason why the underscore character, or there's two reasons why the underscore character is kind of used. One is that it's often used it's kind of used as a supplement for the space character. So, you could say my underscore variable underscore name, and it might just make it easier for you to kind of, see the words in the variable better if you want. The other use that the underscore has as a variable name is some people will use it if they don't really care about what the value is. Like it's usually referred to as a placeholder value, which means it's just kind of there to fill a slot, but they're not actually going to be using it. There's not an example that I can give in this video where it's going to make much sense on a beginner level, but I'll talk about that later. So for now, all that you should really know is that for creating variable names, these are the limitations. These are some alternatives you can use. So yeah, I'll kind of document that right now. And another thing I want to address real quick before I forget is that Lua is a case-sensitive language, which means that whenever you're typing in your program, anything, any word, any collection of characters that is capitalized will be different from those same letters that are not capitalized. So, in other words, if I say name equals 10 as a variable with all lowercase letters, that is seen as a separate variable from name with a capital N equals 10, or if I say name then with a capital E at the end or something. In short, capital letters are seen as different or separate from lowercase letters, so even if they're the same in the alphabet, they are not the same in your program. So these are all different variables. They're not going to be changing the value of each other at all. And actually, because of that, if you do want to use one of those keywords that I was mentioning before as a variable name, one of the things you could do is you could just take the keyword that you want to use and then use a capital letter, or maybe put an underscore before it. So if I wanted, I can't say break equals 50, but I could say underscore break equals 50, or I could say break with a capital B equals 50. So that's what case sensitivity is, or, in this case at least. Alright, so I'm just going to give a few more examples of valid and invalid variables, and when I'm done with that, I will cut to the next part of the video. Alright, so those were all of the syntax rules for variables in Lua. I guess we can start talking about more how they work functionally now. So Lua is a dynamically typed language as opposed to a statically typed language. And those terms basically just mean that you have more control over what types of values you can assign to a variable name. You can set one variable equal to one type of data and another type of data without having to worry about manually handling that change. So for example, in Java, if you wanted to create a variable for a number, you would actually have to specify that it was going to be, an integer or a floating type or a double, and that just means like, a number with a decimal point in it basically. But for example, in Java, you'd have to do something like int, and then you'd have your variable name. So I could say like int number equals 5 and then have a semicolon. So that would be an example of a statically typed language. And then, in Java, sorry, I was almost going to say JavaScript. JavaScript is not the same as Java. So yeah, Java is an example of a statically typed language. So anywhere else in my Java program, I can't just go around and, say number equals anything else that's, not a number. Whereas in Lua, I can do exactly that. I could say number equals 5, and I don't have to specify that it's going to be a number type variable. I can just say number. And then anywhere else in my program, I could just say, number equals anything else. It could be any other kind of data type. Speaking of data types, I think it's time we take a small break from variables and talk about different types of data that we can actually assign to a variable. So very often you'll probably see the term primitive data type or basic data type, and these again are kind of universal throughout most programming languages. Whenever you see primitive data type, it really just means one of three very basic types of data, which is string types, number types, and Boolean types. So I actually have those all in my terminology bank here. So we have string, Boolean. I didn't include number because, everyone knows what a number is. So, but yeah. So the three basic data types, or primitive data types, would be strings, Booleans, short for booleans. People also call them bools, and numbers. So what do these data types look like? I guess we can knock the easy one out first. Numbers. Everyone should know what a number looks like. At least I hope so. So numbers, anything that's a number. In other languages, like I said before, you might have to specify what type of number you want to use, like if it's going to be a floating point, a double. Again, those are just different variations of a number with a decimal place. But in Lua, you don't have to worry about that. Dynamically typed. All of that is handled behind the scenes. So if you want to create a decimal number for a variable, if you want to say number equals 15.8, and then later on say, never mind, number is actually equal to 10, that's perfectly fine. So yeah, that is the number data type. The next is going to be probably the second easiest, which most of you probably haven't heard the term before if you're new to programming, but it's an easy concept. So that would be Boolean, or the bool. And this basically is just a true or false value. So it's just, if you want to toggle something in your program, or if you want to check to see if something is in a true or false state. If you have a property that only has two states, like on or off, that's what a bool value is used for. So I can just say, I can make a variable called bool, and there's two keywords for the kinds of bool values you can have. You can have a true value, and you can have a false value. And those true and false are both identified as Boolean. So it's a little bit more abstract. It might not be clear to most people starting out what exactly you could use stuff like this for, but I guarantee you, as you start learning more and more about programming, you will definitely see how useful having a true or false or an on or off state is. All right, now the third and final basic data type is the string value. And this is probably the most complicated conceptually out of, well, I guess not conceptually, it's pretty easy as a concept, but maybe functionally is probably the most complicated because there's so many things that you can do with string values. It's probably one of the most important out of the three, and the one that you will use the most often. So a string value is any kind of, and yeah, I can't use string because string is a, I guess I'll cover this now. String isn't a keyword in Lua, but there's a built-in library called string. So I'll go into that later, but I'm not going to use this because it already has a meaning in Lua. So I'm just going to say str for an abbreviation for string. I'll say string is equal to, and the reason why it's, one of the reasons why strings are frustrating to talk about or explain to beginners is because right off the bat there's four different ways that you can construct a string, which is by using double quote symbols here. You can also use single quote symbols. There are multi-line strings. So as you can see, these string values only last the line they're on, but just like multi-line comments, like up here, you can also make multi-line strings by just doing two opening square brackets, and then the string will last multiple lines. And then there is the multi-line string that allows you to include these square brackets within the text of the string itself. And you do that by doing a square bracket, the equal sign, and then another square bracket. And then it ends with just two closing square brackets. So, I'm sorry, a closing square bracket with an equal sign, and then another one. So now I can include my closing square brackets in here without it actually ending the string. So that might have been a lot of information that I just threw at you guys. And I'm going to throw a little bit more at you guys. So there's another feature that strings have that I actually didn't include in the original recording of this video, but I did really want to touch on, which I did kind of briefly mention when I was talking about multi-line strings. So for example, if you create a multi-line string with two square brackets, if you want to include the actual closing square brackets as text within your string, If I try to do that, you can see it doesn't work, because what happens is the program thinks that these closing brackets are actually the end of the string. So what happens is now this just becomes my new string, which is just an empty string, and my other brackets out here that I wanted to end the string just become random characters in my program, and this is going to throw a big error. So the way that we get around that is, first of all, you can use the other variant to this, which I mentioned was just this, but with an equal sign in between the brackets, and that will encase these brackets as text. But usually people don't do this because there's just too many rules to remember. It also looks kind of ugly and messy, and it's just best to be consistent. So people, good programmers at least, usually use just one kind of quotation mark constructor, which is usually just the double quotes. So I would definitely just, and these are all that you need. You can do anything else that the other constructors can do with double quotes, and it's the easiest solution. So the only time I would use the other constructors is if I actually wanted to make a multi-line string while I was coding or something. But other than that, I can have any kind of string constructor in here without having to do anything special. But the only, drawback to this is if we wanted to have a double quotation mark in our string, just like before, well, one thing we could do is we could use single quotes. So single quotes could contain this double quote as text. But like I said, typically what people do is they do what's called escaping a character. And the way that you escape a character is, which by the way, escaping a character just means kind of escaping its functionality or one of its prioritized functionalities. So in this case, the functionality of these quotation marks here is to start or end the string. So, if we want to have a quotation mark in our string, then we have to escape its functionality as a string constructor. And the way we do that is by using this backslash character. So if I use a backslash character and then follow that up with a double quote, you can see that they're both highlighted as purple now, or whatever color your editor uses. And this just indicates that it's being treated as one character. So if you displayed this text in the output window or something, or in the UI to a player or a user, you wouldn't actually see this backslash character here. You would only see the double quote. So the only thing that this backslash character is doing is telling the program to treat this as a normal character and not the one of the brackets of your string constructor. So I think that's all I wanted to cover. This might have made the video 1 or 2 minutes longer, but I think it was important to touch on. Alright, so I will be definitely making separate videos on strings. There's a whole built-in library within the Lua language for manipulating strings. That will all be in future videos. But these are the 3 basic or primitive data types in Lua. So I think we can go ahead and move on to the final topic of this video, which is going to be the print function. The print function has one job, and it's essentially just to be used as a debugging tool for the developer. You'll see that I have debug in my terminology bank. Again, debug, if you're new to that term, it just means, well, I'll give you a kind of a root word of that, which is bug. And if you've ever heard, my game is being buggy, or my computer is being buggy, or my program has a bug in it, whenever you hear the term bug, it basically just means that there's a problem or there's an error that needs to be fixed. So debug means, removing that problem, removing that error, and debugging tools are tools for doing so. So print is a function that essentially, its one job is just to take some information and display it into your output console, which I'll show you guys shortly. So I'm going to go ahead and scroll down here, and we're going to start just printing some stuff randomly to get you guys used to the idea of a function. Again, functions, an entirely different video, but for now, just know that a function is basically like a command. So if I go ahead and type out print, and the way that I run the command is I use 2 parentheses here. That's what we call calling the function, or running a command. And then anything that goes inside of the parentheses is data that we're passing to the function to do something with. So we're going to get a basic hello world program started here. Not word, world. And if I go ahead and press Control B, this is my output window, and whatever you're using to practice coding, which I do recommend, Sublime Text. You always want to have access to your output window. Your output window is the most important debugging tool that you can have, because this is where all of the errors in your program are displayed. It's where all of your print messages are displayed. So if you don't know what the value of something is in your program, you can print it. It'll be displayed out here, and you can confirm what you might not know. So again, just make sure that whatever you're printing, if you want to print something in actual text form, that you are using a string value. That's what the string type is for text. Anything that is not in string form is going to be evaluated as a variable. So another thing I want to address real quick is when I said that anything that is not in string form within your print function will be evaluated as a variable. That is true, but only if that thing that's in between those parentheses is actually a valid variable name. So if I go ahead and say print, random word, this is a valid variable name. I haven't defined it anywhere in this program, so it's just going to print nil, which I explain what nil is later in the video. But it's not going to error, is what I'm saying. But it will try to evaluate this as a variable. It will say, okay, this is clearly a variable name. Let me look back in the program and see where you've defined that. It doesn't have to just be a string or a variable name. You can also pass what are called literals to a function, and a literal is any context where you're just passing a value in that moment, and you're not passing a variable that has been assigned to that value. So for example, if I just want to print the number 100 into the output window, I could just put the number 100 there. This would be just a number literal. If I'm just passing a string, saying hello world, that would just be a string literal, and so on. So yeah, that's all I wanted to address. So if I wanted to print the word number, for example, then I would use a string, because I'm actually trying to print that as text. So if I run that, we're going to get number. But if I define a variable called number, and I give it the value of 10, and I don't make my number a string, and I'll just put number in there without quotation marks, then because these don't have quotation marks around it, my program is going to evaluate this as a variable, and it's going to try and find if I defined this variable anywhere in my program, which I did. I gave it the value of 10. So if I run that, it's going to give me 10. But if I didn't define it, it's going to give me it's going to output nil. And I think I should have included nil in one of the basic data types. I'll go back in that in a second. But so if I take this away, and obviously I define number up here, so I'm going to comment that out so the program doesn't execute that. So right now I'm trying to print number, and I have not defined number anywhere else in my program, so if I run that, you're going to see we get nil here. And nil is its own data type. It's not, this isn't like just text that it's outputting. It's actually a proper data type. So, if I write nil in my text editor, you can see it's highlighted as a keyword. So that also has its own value. I'm just going to go up here and kind of include that, because in other languages, it might be called null, but it all means the same thing. So null, nil, void, it just all means essentially that it's a value that means that there is no value. So anyway, now that I've given some examples of different data types, and I explained a bit how the print function worked, let's go ahead and play with some examples of how all this stuff interacts with each other. So as I said before, Lua is dynamically typed, so which means I can assign any kind of data type to my variable without having to, redefine it as what kind of variable it's going to be. So let's say I'll make a variable called unknown. So I'll set that as, we'll make it a bool for now. We'll say unknown is equal to true. Now I'm going to go ahead and print unknown, and because I'm not using quotation marks here or any kind of string constructor, my program is going to evaluate this as a variable, and it's going to say, oh look, we do have unknown that's actually defined, and it's defined as true. So if I run this in the output window, we get our true value that it's associated with. But maybe down the line I decide I don't want it to be true. I want it to be a string value. So I'll just say unknown is equal to, now this is a string value. And if I run that, you can see because our code is executing from top to bottom, the first thing that it saw was unknown equals true. And I was like, okay, well now unknown has been set equal to a new value, which is this string right here. And it did that in this top-down order. So this was the last value that it was equal to. So that's going to be the value that it is, from this line downwards. So, and just to demonstrate that a little better, if I put print unknown here, this is going to still print true right here. And then if I print unknown after that, after I reset it to this, then it's going to print that. So if I run this, you can see in the output window we have true from this print function, and then we reset it to a string, and then we printed that string, which is right here. Now obviously I'm just playing around here with some examples to give you guys a better idea of how this stuff works. But there's one thing that I always like to keep in mind, and I like to tell people to keep in mind when they're learning to code, is that just because you can do something doesn't mean you should do something. So Lua has a lot of features in it that enable you to do things that might not actually be the best practices to do. So for example, it's not very common where you will have a variable equal to a certain kind of value, and then in the same context of your program it changes to a different data type. You don't usually want to do that. The only instance where that is going to be happening is if you're collecting input from a user and you don't know what kind of input you're going to get from them. But even then, that input that you're collecting from a user is usually going to be a string, because they're usually going to type something in a text box or something, or check something in a checkbox. So yeah, just keep that in mind. Just because the language allows you to do something doesn't mean that you necessarily should do it. There's always situations where it's valid, but just do what makes sense for the program and to you. Okay, so I was actually just going to end the video, but I just realized that there's one thing that I didn't cover that I really wanted to talk about before I end the video, which is white space. So this is the last term in my terminology bank here that I hadn't talked about. White space in a program, again, this is a universal term. White space just means anything that is in between characters, symbols, anything. It's anything that is basically a space character in your program. A space character that's not text, you get the idea. So any kind of space between, the equal sign and my variable, or the equal sign and a value. Even different lines, being on different lines. That is all referred to as white space. And the reason why I'm bringing this up is because in most languages, white space actually does matter. So, if in another language, if you do this, your program will probably break. But in Lua, all white space is completely ignored by the interpreter. So doing stuff like this is completely valid. If you want to have, maybe you have a really long variable name and you want to have your values, tabbed way out here and look something like this. It's a very common thing that people do. So yeah, I think that's about it that I want to talk about. White space really just includes anything. It can be the space between variables and the very edge of your script editor. So yeah, I think pretty simple concept. All white space will also be ignored in your program. So yeah. Anyway, on that note, thank you guys for watching. This is the end of the video. I do apologize if I've been slurring my words or something. I don't know. It's 5 a.m. I've been recording for several hours. I hope that you guys got something out of the video, and I'll try to edit it so that, you know, I cut out most of me over-explaining or slurring my words. But anyway, leave a comment, leave feedback. I don't care if it's mean. Any kind of constructive criticism I accept with open arms. So yeah, I'm just glad to try to get back into this series. So anyway, thank you guys, and I'll see you in the next video.